Have you ever seen a loaf of bread? Well, I would hope so. The outside is called the crust. Personally, I like to peel the crust off. But then you get to the inside of the bread. That's the interesting part. And similarly, our Earth has layers. But we can't really see them because you can't cut the Earth in half like you can with bread. I mean, first of all, that's impossible, and second of all, there's civilization here. But for now, hypothetically speaking, we're going to pretend that you can cut the Earth in half, and that the civilization moved to some planet elsewhere. Once again, hypothetical scenario. So if you were to cut the Earth in half, it would look a little something like this. According to theory, that is. Since the Earth's crust is so thick, it is hard to dig below it, thus why it has never been observed. The crust is where we stand. Inside the crust, there's lots of rocks and minerals. These can be very valuable depending on their accessibility and their abundance. But let's dig deeper, to what we call the mantle. Here, you'll find really hot rock, and I mean really hot. And it's really thick, too. To get an idea of just how thick, the crust is 25 miles deep. 25 miles is like a 30-minute drive. Now take that and multiply it by about 72. That's a lot. More specifically, 1,800 miles. Numbers can sometimes be easy to underestimate, so, once again, relative to a road trip, this would be equivalent to the length of a 2,160-minute road trip, or about 36 hours. And if it's hard to dig through the crust, then just imagine the mantle now. But not only is the mantle very thick, but also very hot, as mentioned. The mantle's materials are about the same as the crust materials, except it ranges from 1,800 degrees Fahrenheit to 7,200 degrees Fahrenheit. The vast majority of its materials are solid, but some of it is liquid, due to temperature intensities. I guess we consider this loaf toasted. Below the mantle, there is the outer core. This isn't quite as thick as the mantle, but it's definitely hotter. The outer core consists mainly of iron and nickel, liquid that is. The temperatures range from 7,000 degrees to 10,000 degrees Fahrenheit. And if you thought being outside in 100 degrees was hard, again. It's about 1,430 miles thick, and since we're closer to gravity, it would be a lot harder to jump. It would be kind of like holding an anvil over your head while doing so, and suffering the intense heat that would most likely kill you before you even had the chance to jump in the first place. Now, moving back to our diagram, let's take a look at the core itself, or the inner core, more specifically. The inner core is like the outer core, bearing iron and nickel, except it's 12,000 degrees Fahrenheit, and it's solid. It's also about 750 miles thick, which is not quite as thick as the outer core or the mantle, but definitely a lot thicker than the crust. Although its contents are solid, it is somehow a hotter temperature than the outer core. So we now know what's inside the Earth. Now it's pretty hot and thick, and, well, the pressure is pretty intense down there. But now, let's put the second half of our Earth back on. Pretend the civilization moved back and take a look at the crust. On the crust, there are lots of land formations that have changed over time. Our Earth used to look a little something like this, with all the continents fit together, kind of like a puzzle. Because of many natural disasters over time, they have separated. More specifically, earthquakes caused by tectonic plates in the Earth's mantle. These plates move around due to heat and pressure, the pressure caused by gravity. This all accumulates, and on Earth's surface, starts to make things split and crack. I'll break it down for you. There's convergent, divergent, and transform boundaries among these plates. When these plates slide toward each other, they are known as convergent boundaries. These can make mountains and land form. When these plates slide away from each other, they are known as divergent boundaries. And these can cause earthquakes, but not as much so as transform boundaries. Transform boundaries will slide past each other, and from lots of friction and pressure, it causes impact as great as multiple bombs. This causes the crust to crack and split. However, these plates only move 2 inches a year, so these kinds of earthquakes are rare. On the other hand, minor earthquakes can occur quite often, and are sometimes unnoticeable. Because they move a very small distance in a rather long span of time, it has taken millions of years for the supercontinent known as Pangaea to form into the 7 continents we have today: North America, South America, Africa, Europe, Asia, Australia, and Antarctica. So now you know how your home is just like your breakfast in a way. Well, I hope you enjoyed this, and thanks for watching.